Hey, so good evening, everyone, and trust we are doing great. So I think the last was actually mentioned that we're going to be starting machine learning today, right? We're just going to talk briefly about what machine learning is, and also just get to like create a machine learning model, right? And we'll also talk about like different algorithms itself, just so I can better understand how it works and all that. Okay, so when you see machine learning, like I said, when you hear the word machine learning, it's called machine learning because the machine learns from something, right? Now, you build something that learns from data, right? If you look at what you are building is more or less you are building a machine, right? And the machine gets to learn from data, right? Yeah. So yes, you have the machine gets to learn from data. So which is why it's called machine learning. So when you hear machine learning, it simply means that the machine is learning from something, right? Which is why it's called machine learning. So you get to learn from data, right? And when it learns from data, it's actually able to make predictions or decisions without being programmed. Now, this is what this means. Now, before now when we looked at what's what we looked at writing your for loop, writing your if state, right? Now, the whole essence of using the why this is why you see that we call it control flow. Is that you're trying to control how the program is going to be executed. For example, if I say for this in this, do this, it means I'm trying to control how the stuff is going to flow. Or it means if I say for I in range of 6, print I, say it means I'm telling the software, you know what, guess what I want you to do. I want you to go through this list and try to what print out the result, each item you have in the list, something like that, right? Now, if you see something like that, you can easily tell that because the reason why we get an output is because we programmed it to do so, right? But now in machine learning, what you are saying is all we need to do is just to ensure that provide what it needs to learn from, right? Which is the data. Once it learns from the data, it's now able to make predictions based on what it has learned, right? So it means we don't necessarily need to tell it what to do, right? Because it has learned from the data. Once you say, okay, what do you think it's going to be? It should be able to give us the result. Okay, based on what I've learned, this is how it should be, and this is also how it should be, right? Something like that, right? Oh, there are like different reward applications of machine learning, right? So from your spam detection, yeah. So from your spam detection to recommender systems to voice assistant to medical diagnosis, fraud detection. So these are areas where machine learning is applied. For example, you get an email from someone right now, the model or the machine learning model is able to like dictate whether this email is spam or not, right? Based on so it's able to do that because it does learn from data. Now, when we say, oh, we are trying to train a machine learning model, the whole essence is you're trying to learn. So if, for example, now someone tells you, oh, I just enrolled for a program, right? So it means if I say, oh, I just enrolled for a program, like it's like, oh, this program, they are trying to train people in AI, they're trying to train people in this. Now, the whole point of training is like those students are trying to learn, right? Now, what I'm saying is when you say, oh, you are training a machine learning model, what it means is the model is learning from some. So this is the phase where the model gets to learn, right? It actually learns from data itself, right? Now, like I said, there are also like different applications of machine, like I mentioned before now, recommendation system. For example, Netflix, right? How is Netflix able to like, suggest movies you like, right? The model, like I said, the model has been trained to like learn from data. Now, based on what it has learned, right? They get to create a recommender system that's able to recommend products based on your browsing history. Like I said, it has been trained to do that, so it's easy for it to just do all of these things. So there are also like other applications that I've listed, like medical diagnosis, fraud detection, to whether to identify fraudulent transactions or not. So these are like cases where machine learning is being used, right? Now, for this particular for this class, what you're going to be using is you're trying to predict. So what you're going to be working with is um the data for a bank, right? Now the thing is, the whole essence is they are trying to predict those customers that are likely to leave they're likely to just, now those customers are likely to churn. Churn will mean that those customers are likely to leave, right? And the essence of doing that is if we are able to identify those customers that are likely to leave, right? We can try to find out what the problem is. Is it that they are not okay with our services, or there's something we need to improve on? Do you understand? So if they're able to identify those customers that are likely to leave, they can now think of or come up with strategies to ensure that we do not lose customers, right? Because if you look at it, right, I feel like it's easy to retain customers than acquiring new ones. If you are trying to get new customers, for people who work in the bank, most of the time they will most likely maybe go to different companies, or maybe like, so you see people on the street trying to advertise, oh, come on, open an account or stuff like that. So just imagine the whole stress of acquiring new customers, right? Why not just think of strategy? Obviously, you want to acquire new customers, right? But what I'm trying to say is it's more expensive to acquire new customers than retaining those old. So if some people are trying to leave it, we need to find out why are they leaving? Is there something we are not doing properly? Is there something we need to improve on, just so that we can really ensure that these customers do not leave? Right. So what can we do? So the best thing we can do is let's create a system that can help us identify those customers that are likely to leave us. So if we can identify those customers, now um we can now think of strategies. Okay, what is the problem? Right? Why do these customers want to leave? Is there anything we can do better? Maybe give them discount, not discount, maybe like recommend this. No, maybe perhaps it could be that maybe um the rate at which we get to treat customers, maybe they are not really okay with that or something, right? So let's just think of which just ensure this customer will not leave, right? Which is what essence of we creating a model that can actually do that, right? Now, what we are going to do is we're going to just create a model that can predict whether a customer will leave a bank or stay, right? Which is whether you want to call it customer default rate prediction, you want to call it mention itself, right? Like I said, so I think I really just the explanation I gave just fully on explains what churn means. Churn means, oh, customer is leaving. What can we do just to ensure that they do not like leave, right? So now since we've identified the problem and we know what we want to do, we want to like create a system that can easily just tell us those customers that are likely to leave, and those customers that are likely to, so those customers are likely to stay, now. So focus will now be on customers who are likely to leave, right? So what can we do to just ensure that we do not lose customers, right? Now, when you want to build a machine learning model, like I said, the most important thing is data. If, for example, now you identify a problem, try to solve a problem, and I say, okay, this problem, what we can do is we can create a system that can help us identify this, that can help us identify that, right? So the next thing would be, what are the most important things we need to take note of? What are those things we need to do? Oh, we need information about this, we need information about that. Now, this is where domain knowledge comes in. For example, now I'm trying to build, let's say I'm trying to build a system that can let's say in the clinic setting, for example, let's say they are trying to build a system that can easily dictate whether a patient has dementia or not, right? Or if at all a patient has dementia, it's able to tell you whether it is early, it is mid, or something like that. Now, if you look at it, you are not a medical, so which means that if you are going to work on something like that, you most likely need to meet an expert. You need to come out with a medical doctor or different medical doctors. Okay. For something like this, how do you guys detect this? How do you guys like, because obviously you're not a medical doctor, so you need to really ask questions. What are the type of data you're going to need and stuff like that? For example, now I'm trying to work on something like that. I didn't know, okay, the doctor will explain, oh, for something like what we do is we conduct the MRI scan on patients. Once we get the image, there's a way we are able to detect, oh, whether this patient has this dementia or not, that based on the scans we've conducted. So what we can now do is, so why not just, so if the doctor tells you these are what we need, right? So what we can do as data science will now be to extract those parts from the image, you understand? And now start classifying them. Okay, so it means that we could find a way to just limit it. So for something like this, what do you feel? Oh, the doctor could tell you, oh, this means that this patient does not really have dementia. You understand? So it means we need domain experts to be able to like identify those. Oh, it means we able to prove that okay, these are images of people who have dementia. These are images of people who do not, right? So you can see the whole explain the reason why we actually need like domain experts, right? So like I said, The most important thing is getting data. So if there's no data, you can't build any AI system. That's the ChatGPT of this world, the code of this world. The reason why we can have these things is because we have these things are trained on data. So just imagine there's nothing like data. We won't even have these things, right? So for every machine learning project, right, like the most important thing is getting your data. So now the first thing we're going to do is to import the libraries that we need. What are those libraries that we need, right? That's what we are going to do, right? So we're just going to like import those libraries. Now, here are some of the libraries that we need, right? And I'm just going to explain why we need these libraries. For example, we actually need the pandas library because we are trying to read in the data we are trying to work with is in a CSV format or a CSV file rather, right? And we need a library that actually allows us to like load the file and we can now, now do whatever we want to do with it, right? So we also need NumPy just in case you want to do calculations and all that, right? Matplotlib and Seaborn, you know what those ones are used for. In case you want to just create visuals from our data, right? Scikit-learn. Yeah, let me just talk about sklearn. Now, sklearn in full is called scikit-learn, right? Show on record. Oh, okay. So scikit-learn, right?
Hello guys, information is facing our technical issue. We'll join back.
It's all right.
Okay, so I think I was actually talking about different libraries. I said the scikit-learn, like I said, you get like a lot of libraries from it, and you also just get like the different algorithm, whether it's logistic regression or your gradient boost or your random forest. These are this thing I can actually get from the scikit-learn library, right? You also have XGBoost and LightGBM, but these are more or less like advanced algorithm, advanced machine learning libraries, right? So we will just see how we get to total of these things, right? So like I said, the first thing I want to do is to import pandas as PD, right? And now let me just add this. Now because like I said, the XGBoost, although I'm not sure we might be able to get to XGBoost today, but you most likely have to install it. So I think if after we get stuff, I can actually just do that with part, right? So import pandas as PD. I also said I'm going to import the numpy as np. So let's also import this. So the thing is logistic regression or linear regression, um they are linear models. So what it means is we are going to import logistic regression. It is in the linear model of scikit-learn. So this is how you get to import it, right? So anytime you're trying to import logistic regression, just now you are going to import from the scikit-learn, the linear model import logistic regression. And because you also get to evaluate our model, we also like to like import the matrix you're going to use. And like I said, the good thing is as we code along for each of these concepts, I'll get to just explain that, right? Just so that we don't waste too much time. So you're going to need accuracy, right? So you're also going to need precision score, right? I said I'm going to explain each of these concepts as we continue, just so that it flows. So I'm also going to import recall score and something called F1 score. Like I said, I'm still going to explain that. We'll also get to, so this is just us just trying to import all the libraries you're going to need, right? So I'm also going to import these. Like I said, I'm going to explain why each of these is very important, right? So now because you're actually going to process our data, right? So we actually just need to import this thing. So I'm going to import label encoder. Like I said, as we move along, I'm going to explain um why each of these things are really important. And I don't know the actually needs to like split our data into train and test, so which means that we're going to what import this. These are the libraries we are going to need to train, test. Okay, then okay, okay, that's okay. So like I said, so these are like libraries we are actually going to need. These are like libraries we are going to need. Now, like I said, I think I already explained what each of these does. For example, pandas is for us to not to just load and manipulate data. Then this is logistic regression because we are trying to use logistic regression. And let me just add this. Okay, so these are the we also get to do. Let me just import this decision tree classifier is also another algorithm. So, like I said, each of these things, once we this thing, I think it's just best that I'll just explain that so I don't cause with too much explanation and I forget what I mean by this thing. So this is like the last thing I want to import. So yeah, I'm just import. The reason why I'm importing them now is just so that just so that it can be structured. You know, we've actually imported every single thing we need, right? Okay, so classifier and let me just leave it up here. Now, like I said, so these are like different libraries that we need. So the algorithms are logistic regression, decision tree classifier, not first. And I'm wondering, Victor, why are you importing classifier? Or is so when you say classifier, doesn't necessarily mean that oh yeah, application. So I think before now, I think I mentioned that we have to what's the word now? Other supervisors, we actually have like two different types. You actually have classification and you have regression. And I also think that before now, I actually explained supervised learning, not supervised learning. Right? Now, what we are doing is supervised learning. So under supervised learning, you have classification, you have regression, right? Supervised, let me explain. Supervised learning, the straightforward explanation will mean what is supervised learning means that you're trying to train a model, right? Have the input and you also have the output, which means that for this particular input, this is thought to be the result. For this particular input, this is thought to be, which is why it's called supervised learning, right? So, but all supervised learning, you only have input to mean, when I say output, now you want the AI to predict something, right? Now, when it's predicting something, that's like the output. So it means you give the model data just so that it can learn. And then the day is able to what make predictions, right? That prediction is what's an output, right? Now it's able to do that because you're giving different examples. Now let me just give a very practical example. Now I come to a class and I'm trying to maybe like just teach a particular concept. Right? Let's just say a mathematics topic in masters, for example. And for every example, right, I give the results. So, for example, let's say I'm trying to teach on different type of equations, linear equation and quadratic equation. Now, the first example I give, maybe x plus 3, I can come and say, oh, this is linear equation. 2x plus 4 linear equation. At the moment you start seeing x squared plus 2x, you already know it's what quadratic equation, right? Now this is possible because I've given different x. So it means I already say x plus 3 is linear, 2x plus 4 is linear equation, quadratic equation, x squared plus 2x is so it means once the model sees, I'm just giving an example. So once you see 2x plus 3 or x plus 4, sometimes they'll just only include x, whether it is x alone or x plus 2 or x plus 5, it's just only x. You already know, oh, this is an example of linear equation, right? But once you start seeing x squared, or you see x squared plus 2x, or you see x squared plus 4x plus 5, you already know this is what's quadratic. Now that is supervised, which means that I've given you the examples, and I've also given you the answers, right? Now, but for unsupervised, right, you only give me the examples. Now, I expect you to find the answer yourself, right? So it's like I just give you different equations. Now you now have to now start group. Okay, I think this maybe x plus 2, x plus 3, x plus 4 are similar. So maybe this should be in one group. Maybe x squared plus 2x, then another one, maybe 2x squared plus 3x. This should also be in another group, right? You can see in that case, in this scenario, I'll just give examples, but I do not to tell whether this is linear equation or this is for that. That's just like a very practical example of difference between supervised and unsupervised. So when it is supervised, supervised will mean that you have you have your inputs and you also have the output, which means that for each input, there's always an output provided. So the model knows that for any if I say any input like this is what the answer is, right? For unsupervised, there is no output in the data. So it means I only just give you the data. You can see the input, but I didn't give you what you are predicting for. That's the target variable. So it means for supervised learning, you always have the target variable, right? Unsupervised learning, you do not have the target variable in your data. That's what I mean. Supervised learning, there's always going to be the target variable as part of your data. But for unsupervised learning, there's no target variable as part of your what data. So these are like the libraries. Like I said, we are just going to import, right? So the algorithms are going to be looking at is the logistic regression, decision tree classifier, and not first classifier. Now the reason why we are saying classifier. Now remember this is a classification problem. Sorry, this is a supervised learning problem, right? Because it means that in our data we have customers who are still with the in the bank. We also have details about customers who have left the bank, right? Who are no longer customers of that particular bank. You understand? Which means that we actually have targets as part of our data, right? Now, so the question will not be, I know that I know it's supervised. So is it classification or is it regression? When you say classification, you're either predicting for something or this. You're either predicting for this, that, or the other thing, right? But for regression, it's continuous. It's numbers. So if for example, I say, okay, I'm trying to create a model that can predict the price of houses, right? Now the thing is, I can't. So that cannot be a classification problem because you could have a two-bedroom apartment in Lekki. It could be like maybe 200 million. I'm just giving an example. Then you could have another that same apartment, like two-bedroom apartment on the mainland, be like 13. I'm just giving an example, right? Now it is not fixed. So you can see it's continuous, right? So for that kind of thing, you already know it is regression because it's continuous. You're predicting for numbers, right? But for classification, it's either it is this or it is that. If I say I'm trying to create a model that can predict whether someone is going to get a loan or not, so either the person gets a loan or the person does not get a loan. Fine, so that's what classification. Now, for what you're trying to do, you're trying to predict if the customer is either going to pay or the customer is either going to leave. So it is what classification. This is why you can see I have classifier, and the likes, right? These are the libraries we get to import. Let me just check the so this is the data I want to work with, right? So the next thing we want to do is to load the data, right? So we just go df equals pd dot read underscore csv. Uh, so just to be sure, let me just copy the name. Okay. So this is what we want to import. Okay. So did I run this? Okay, I didn't run this. That was why. So we have to run this first. And see, let's try to run this first. So still, then let's now try to run this. Okay. Saying there's no blah blah. Okay, so it's saying there's nothing like that. Let me see. Come on. Let me try to do that again. It's still loading. Okay, so let me just. So I think so. The thing is, this stuff is of two types, but I think I put them in this in different folder. So this is why I'm trying to run this. Okay, then let me also copy this. So because it can't, so the folder where this is, it can't see that. Yes, so can't see this. So I'm gonna close this. Right. Okay. Okay. Yeah. Okay. So let me just. So now that we know we want to just see the let's try to check how the data is gonna be. You can see this. See this, right? This is right. Now this is what we are focused on, whether it is gonna default or not, right? Okay. Let's so now this is just like me explaining what the data, the different columns. And you can see you can actually see like different columns, right? So because if I do df dot info and we check this, you can see this. Look at the difference. So what this means is we have 30,000 rows, right? And from what we can see, you can see the unknown because 30,000 entries, which means that looking at this, we do not have any. Well, let's still try to understand the task everything. So now this is the breakdown explaining each of the columns, what each column represents, right? Now, the customer ID. Now, this is the primary key. So I'm going to use that one because it uniquely identifies each row. So it's like saying, because we can't have a customer name, right? Because of privacy. So what they will most likely do. So each customer will most likely have their ID, right? So it means customer ID, like I said, unique identifier for each customer, right? Okay. So okay. Now, this age is just explaining, we're just saying that, okay, the age of the customer, the gender, whether the person is male or female, education level, right? On scale of 1 to 5. 1 means below college. So this is just explaining different columns you have in data. So I don't necessarily need to start explaining each of them, right? Departments, the job role, the monthly income, like you can see years at something, years in current role, and stuff like customer satisfaction with their job and all that. So this is just explaining what each of these represent, right? Okay, so now let's continue. Now you can see I'm going to predict the default column, which is this. Let me try to scroll so you can see this is what you are predicting for. Yes, no, you can see this is the target variable itself, right? Okay. So yes, so I can just come here and let's do df.describe. I know what df.describe, you know what it does, right? So this is um just telling us the different counts, mean, standard deviation, mean, effects, and the likes, right? Now let me just stop here. How do we check for missing values? You can just drop the answers in the chat. How do we check for missing values? Now you can see what we did. The first thing we did was to just, now load. So it's just like the whole pandas. You load your data, see your data, what else? Just check, try to understand your data. Then, yeah, what we are trying to do is to check for missing values, right? Let's see how we can, what's the word? Let's just see if our data has missing values. Now that after missing values, we can now start processing the data. After doing that, before we now start dividing the data, then you now give it to the model to learn, then predict and all that, right? Now we like to check for the missing value. Now, how do we check for the missing value? Like I said, it's to be df dot is null, then dot sum. This is how you check for missing values, right? So you can see this is just telling us that there are no missing values. You can see this. So this is just telling us that there are no missing values, right? Okay.
Sorry, Mr. Victor.
Yes, please.
Yes, sorry, the internet has been throwing me in and out. The
Okay.
all the library you loaded, sir, is it
Yes.
necessary or compulsory that we must load everything, or is going to be based on the questions given or what we are trying to achieve?
Okay, so to answer your question, yes, so let me go back to that piece, right? So it's based on what you are doing. Now, libraries that are compulsory, pandas and numpy. Pandas is compulsory, right? Now, these libraries, right, they can be optional. Why did I? Now, it depends on the algorithm you want. For what we want to work on, we decided to take, we want to go with logistic regression algorithm, decision tree algorithm, random forest algorithm. These are the three algorithms, which is why I have to import them. So if you are using another algorithm, there's really no need for us to import this. I said, we want to use logistic regression, we want to use decision tree, what do you want to use? Now, once as we continue, I'm still going to explain each algorithm. I'm trying not to explain that because we've not gotten to that part, right? Now, okay. So the reason why I have to import these three is because these are the libraries for these are the algorithms. Now, this is also very important. Why? Because we'll use this to evaluate the model's performance, which is why it's important, right? Now, this is also important. Why? Because now, when you say label encoder, now our data is going to be there are some columns in our data that will be categorical. You know what I mean by categorical, right? Like they are not numbers. So before you give to any machine learning model, you have to encode. When you say encode, you mean you're converting from categorical to what numbers. So this is what I mean. So instead of you saying yes or no, I can say yes is one, no is zero. What have I done? I've encoded it from category number. So you also need it. Now you also need it because you have to split your data into training and testing. But see these three, it depends on what you're. So if, for example, now the only algorithm the regression. There's no need for me to import decision tree. There's no need for me to import random points. Why? Because the only algorithm I want to do is but the only reason why I actually decided to import it here is because these are the three algorithms we want to use. So I don't know if this answers your question. Janet, please.
Yes, thank you. It does.
Oh, okay. Okay. So now this NP, the random seed. Let me explain this. Right. Now the thing is, one of the reasons why you need a random generator is because anytime you run if for example now I write my code, my Jupyter notebook, right? And I rerun it. I'm trying to explain where random is from this bit, right? Now you also see when we get to train test, you also specify a random seed generator. I just want to explain everything in total and everything in detail. Now the reason why you need is because now if I run my, let's say for example, now like I said, after writing my code, it's my Jupyter notebook. Now, if I do not specify a seed or like let me say a random number to let me use that word, right? Now, if I run my code 5 times, I'm going to get 5 different results because every single time I'm running it is generating because it's shuffling to generate new samples. So if, for example, now it's speaking from this to this, now to shuffle and generate. So like every single time I run it always gives a different results, right? Now, because that's just the way it is, it's not stable. Now, the only way for us to ensure that even though I run this code 10 times or 1,000 times, I still get the same result. It's by saying random number. So when you see random number as 42, so it means if you like, when you say 2,000 times, the random number generator, the thing for this is going to be 42, right? But to ensure that it's always still going to generate the same samples. Now, when I want this sample will mean that, like I said, if I run it, if I say split this data, now, we are leaving it to split. You're leaving everything, like you're leaving it to split the data, right? Now, it could, when it's splitting, you're not controlling how it's going to split. You're just taking 80-20. Now, it could pick, so it's just like saying, I don't know how you want to split, but just ensure that it split into 80 or 20. You can do it anyhow. Maybe pick from this, pick from that. Now, this, like I said, when you run this thing over and over again, you just realize that you're going to get different results. Now, the only way for you to ensure that your whatever results you get, whether it's 90% accuracy, 34% accuracy, is still stable. Is to just set it, right? Like I said, you even still set it in plain test it, right? So this is not so that's just the whole exercise. It's just to ensure that every result that is being generated now can be generated even though you run your code 1,000 times. So I don't know if this answers your question, Messi.
Mm,
Yes,
yes,
correct. Yes.
yes. Please, sir, please, I want to ask, okay, is like this np.random.seed bracket 42, is it like a constant that we have to put? Or we
No,
can
so you
change
can
the
use yeah, you
number?
can change the number. You can change the number. You can change the number. You can
So,
change the
like,
number.
what is the significant of that changing of the number?
So sometimes when you change, so yes, it is. Sometimes when you change the number, it could improve the result. You see, one thing about the data science, you don't we don't necessarily have one best way of doing something. It's like you try something, see the result, try changing something. So it's just like saying hyperparameter tuning. You have hyperparameters in your algorithm. You change a value, it gives you this result. Change another value. So that's just the whole essence. Like you trying and seeing, okay, I think when I change it to 25, when I run this, I got 90%. Okay, let's change it to 100. When I run it, I got 95. I got 95, right? So you don't necessarily have like the best value to go with or something, right? So it's just the whole essence of you changing it. You might change it and it can improve performance of your model. That's just how I don't want to say that's how weird it is, but that's just the way it's actually. So I don't know if you get what I'm trying.
Yeah, yes, I get what you're saying, sir.
Okay. Yeah. Welcome. Okay. So this is where I stop, right? So check for missing value. So I don't think I really need to explain this, right? Now this is where I want to explain. Now let's do df.info again. Let's do df.info again, right? Now what you notice that some columns are objects, right? While some are integers will mean numbers, right? Some columns are objects, while some are numbers, right? Now what this would mean is that now if you look at this customer ID, we don't need it. It's not important because the customer ID just only just uniquely identify each customer. So it's not needed. So we are not interested in it. Now the thing we are interested in is this, right? I think that's apart from these two, those are the things. Okay, there's gender and default next month, right? Now there's a way you can select the data. I'm just looking at it manually, right? So we have gender and we have default next month, right? So instead of you just looking at it manually, there's a way you can actually just select the data type. So let me just say, let's call it categorical. So let's just select those categorical columns. right? So I'm just gonna say categorical columns. Sorry. I'm trying to select those columns that are categorical. Df dot select the types. To include equal, I'm gonna explain. I'm just trying to write this. I'm saying what I'm doing. That's columns. Okay. So let's print. I'm going to explain what I just wrote. I'm just trying to just print it. No, I think I'll see to go here. So I'm writing again. Let's just copy it in the brackets. Okay. Now you can see this. Now, what did I do here? Now, I'm only interested in getting categorical column, and the reason is because I want to encode. The code will mean I want to convert it from categories to numbers, right? Which is why it is encode, like you're encoding something, right? Now, let me just quickly explain what is this. Let me explain this. Now, if you look at your data, you notice that there's object and there's integer. If I'm going to encode some, so the rule is, Victor, the only thing you can encode is categories. Okay. Since I know I can encode categories, so it means that I need to extract those columns that are categorical data. So what it means is any column you see object, it means it's not a number, right? So how do I extract those columns that are categorical? Don't worry. All I need to do is just to say df. df is the data frame where data is stored, right? So we say df dot select data type. So it's like we can select data types. Or the way you write it, select underscore d types. So which data type do you want to select? I'm only interested in objects. Can you see? This is why I said include object. You can see this. Now, once including, remember I said each of these are columns. This is a column, this is another column. Do you understand? So it means after selecting, so it's like saying, Victor, I'm interested in getting categorical column. So how do I do that? Okay, you say you do df dot select as for d type. So anywhere you see where that type is equals to objects, please let me select those columns, right? So how do you do that? df dot select underscore d types includes equals to object, which means that the things I want, the only thing you should just include in what you're going to return to me is those ones that are objects. No, I'm not concerned with those ones that are integer. Just include only those ones that are objects, right? And for you to access each of, because remember I said these are different columns, so you have to say, okay, I'm interested in the columns. I'm not interested in every single thing, just the columns. That's what I want to work with, because it's the column names you want to just now you want this is what you're interested in, right? Dot columns. And the reason why I said to list is so that when we print it, that we can see the result in form of a list. Can you see this is a list? Can you see this? That's just the reason why I said, okay, you know what? After extracting, just print, don't print it out like that, just put it in the list so that it looks neat, right? Which is what we did. Now, if I had come here and say exclude, let's do it. Look at something. Can you see this? Exclude will mean remove those columns that are objects. So you get the logic, right? So because here we want to include, we'll just use what include. So you can either use include or you can use exclude, right? So does that mean there's no? So the reason why I'm selecting this categorical column is because I want to encode it first. You understand? I want to encode, which is why I'm selecting it. I just want to encode it. That's why I'm selecting it. So it's not like that's the only thing I'm going to work with. I just want to I just want to encode it. That's why I had to just select that part. Yes. So that's the reason. Right. So you can see this. So if I run this again, you can see that these are the categorical columns we have in our data. Customer ID, gender, then default, next one, blah, 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 and stuff like that. Right. So let me just stop here to see if we're all on the same page. I don't want to look like I'm going too fast. Right. I want to be sure that we're all on the same page. So if we're all on the same page, you can just drop one in the chat. Please, if everything I've said is not clear, please just let me know so that I can go over it again. I just want to be sure that we're all on the same page before I continue. So if it is clear, you can just drop. Okay.
It's not clear.
Let me try to send it again. Okay.
Please, sir.
So,
Sorry, sir.
yes. Yes.
Please, sir. I'm so sorry, sir. When you started the class, I was not there. So I just wanted, though I know we are doing machine learning today. I
Yes.
was there when you explained when we started step one.
Okay.
But like I just wanted to understand the significance of machine learning, blah blah blah, like that.
Oh, okay, 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 no problem, no problem. Let me just try to go right with you. So I said that so here's the thing, right? So the data, so this data is for a bank, right? And so the thing is they notice that some customers are leaving, right? And some customers have left actually. So if some customers are maybe leaving the distance to become customers of another bank, then it means something is wrong, right? Either something is wrong with the bank or it's just personal situation or something, right? Now, so what they want to do is why not just create a system, right? Now that system will tell us those. So now some customers have left, right? The customers have with us. Now, but we already have the record. We have the record of those customers who have left. We also have the record of customers that are still with us, right? Now, what if you create a system that identify those customers that are likely to leave, right? Because those customers they've left, so they've left. So I don't think there's anything you can do about it, right? So now for customers that are still with us, right? Now there could also be a possibility that someone might still, that someone might still switch, or someone might just maybe close their account with us or something, right? What if you create a system that can help us identify those customers that are likely to leave? Now, if the system can identify those customers, now this is where our strategic managers come in. They can now brainstorm what can we do? Why are this why is it that this customer that is looking more like that this customer should leave us? Is there something wrong? Is there something we can do? Blah 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 stuff like that, right? So they brainstorm. But first thing, we need the system that can help us identify those customers that are likely to leave. So the strategy managers can now brainstorm and figure out how to provide a solution, blah blah stuff like that, right? Now, the whole essence, you want to create a model that can predict customers that are likely to leave or customers that are likely to stay. But our major focus is customers that are likely to leave. Because if customers are likely to stay, that is not a problem. So it means we need to focus on those customers that are likely to leave. But then now think of, is there like a similarity between these customers? Maybe we need to do, is there something we're not doing right or something, right? Which is why we need to create a machine learning model. Now, in the first instance, what we did was to just import all the libraries we're going to need, right? Now, after importing libraries, you have to load the data. Then we decide to just read the data. This is the first 5 rows of the data and all that, right? Now we decide to check, what info does. Let's see the different columns for our data, those ones that are integers, those ones that are categorical and the likes, right? Okay, Bella, please. You raised your hand, please continue.
Oh, okay. Wait, so you already explained the part of the categorical versus the classification, right?
Yeah, I already explained that part, yes. Okay, you don't understand that part.
I don't know. I was just my head is still booting because I'm lost. But go on.
Oh, okay. Okay. So, okay. So the thing is, I think we actually did it before now. So we have 3 times of machine. We have supervised learning. We have unsupervised learning. We have reinforcement learning. But our focus is on supervised learning today, right? Because we are not doing unsupervised learning. Now, when you say supervised learning, it means that you already have your target variable. Like you have your target variable as part of your data you want to use to train your model, right? I think I give the example of imagine a scenario where I'm trying to just see the difference between linear equation and quadratic equation. So if I come into the class and I give an example, and I say, okay, this example is an example of linear equation. This example is an example of quadratic equation. Now, what that means is even when I now decide to give exercise, the students are able to identify that, oh, based on the examples he has given us, if I say x plus 4, I already know this is what linear. That is supervised, right? But for unsupervised, imagine a scenario where I just come to class and I just write different equations. And I say, figure out which one is linear, figure out which one is quadratic. You can see there's no target variable as part of the input that is being given up. That is unsupervised, right? Now for supervised, you have classification, or you have regression. Now, when you say classification, classify, so either you're classifying something to this group, you're classifying something to that group, right? And I also went for that to give an example. Now, if let's say I'm trying to predict the price of apartments in Lagos, looking at that, that can never be a classification problem. Why? Because you could have a two-bedroom apartments on the island. It could cost 250 million, 300 million. That does not mean that because it's two-bedroom apartment, it means that if I also come to the mainland, that price will still be 300 million. It's not fixed. It's continuous. So you could even come to the mainland, you could see that same apartment for like 50 million, right? Something like that, right? You can think in that case, it is continuous. It is not fixed. It's not like, oh, is that so it's not like it's something like anytime you see a two-bedroom apartment, it is always 100 million. Or anytime you see a 40-bedroom apartment, it's always 100 million. That's not the way it is, right? So it is continuous, it is not fixed, which is why it is regression, right? Over classification. So imagine I'm trying to predict whether a customer is going to get a loan or not. Is either a customer gets the loan or the customer does not get the loan. Do you understand? So it does not have to be two. It could be four classes. It could be five classes. Either you are predicting for this, you are predicting for this, or you are predicting for that, right? But it is not continuous. It's fixed. It's either it's going to be this, or it's going to be this, or it's going to be that, right? You can see it is what it is classification. It is a classification problem. That's what it means, right? Now, in this case, we want to identify those customers that are likely to leave. So there are two scenarios, either the customer stay or the customer leaves, right? So is it continuous? No. Because it's not continuous, this can never be a regression problem. So if it is not a regression problem, then it means that it's a classification problem. Because we've already established the fact that this is a supervised learning problem. So either it's classification or it is regression. But based on what you've analyzed so far, it is a classification problem because you're trying to predict whether the customer is going to stay or the customer is going to leave. There are two options, either you stay or you leave, right? That's just the way. This is why it's a classification problem, right? Now we just like to just check the different data type, just looking at the data and all that, right? Now this is just explaining the different columns because if you look at this table, for example, you just have customer ID, credit limit, gender, education, right? You're wondering what does each of these columns mean. So this is just explaining what each of the columns mean, right? So that's just it. Mercy, please.
Sir, you
Uh,
said this one that we are doing is a classification, not regression. So
yeah, no regression,
why
yes.
yes, why is it that we are still importing linear regression?
No, we didn't import linear regression.
Like
So
like from
okay,
the
oh, okay, so
import
let me explain. Yes, let me explain. So the thing is, there are different linear models, right? I'm just going to focus on, I won't talk about the XVM, just focus on logistic regression and linear regression, right? Now, they belong to the same class. So just like saying we have a linear model algorithm. So the question is, what are the different linear model algorithms we know? I know there's linear regression. I know there's logistic regression. Now, linear regression and logistic regression, they belong to the same class, the same family, but they serve different purpose. Linear regression is used for regression purposes, right? While logistic regression is used for classification purposes. But they bear the same name, but it's different. Linear regression is for regression problem. Logistic regression is for classification problem. You can see they both belong to the same family regression, right? Like, oh, linear model family. But logistic
yes.
regression, you only use it for classification. Linear is only used for regression. I don't know if you get the difference now. Oh, okay.
Okay.
Yusuf, please. Go ahead, please. Yusuf. Balon, right? I think I saw someone.
Yeah,
How do
yeah,
I know
sure.
okay. Go ahead, please. Just for answering this
How
question.
do you know what? Sorry, you're always calling me so anyone, Bola, anyone. It's fine.
Balon, Balon, go ahead, please.
Yeah, so like from what I used to know before, like what I used to maybe know classification against categories. Maybe if one is predicting numbers, right, and one maybe you're trying to get maybe this one falls under maybe like true or false or 0 or 1, that kind of thing that falls under Boolean or something you're trying to detect, that kind of thing. That's
Okay.
what I understand. So now it's now looking different. That's why I'm not
No,
really.
okay. It's still so it's still the same. If I say true or false, so it depends on what you're presenting for. Now let's look at this data, for example, right? Let me go up so you can see clearly. Where is it? Where is it? Where is it? Where is it? Now, if you look at this, this is the where is it? This is the target column. Target column is yes or no. Can you see that? Now, there can also be a scenario where the target column could be true or false. Do you understand? So it depends on the data itself. Some data, maybe perhaps the way they represented true is yes, the way they represented false is no. Do you understand? Right? So when you say classification does not necessarily have to be binary. You have binary classification, you have multi-class classification, right? So let's say that you try to predict whether an image is a cat, a dog, or a goat, for example. I'm just giving an example. Now, you see, these are three classes. Whether it is cat, this picture is a cat, or it's a goat, or it's a dog, right? This is classification because either it is cat, or it is dog, or it is goat. But for regression problems, right? It's not fixed. You can predict one, you can predict two, you can predict four, which is why I give the example of pricing, right? So, for example, now a apartment in this place could cost 20 million. Let the model predict 20 million. Now, that same apartment in on the island cannot be 20 million. It will be like 100 million. Do you understand? Now, it is not fixed, so the value changes, right? So you don't necessarily have that, oh, either it is 100 million, or it is 200 million, or it is 300 million. There's nothing like that. You could get an apartment that they can tell you is 264 million. If you see another one that can tell you is 394 million. So you can see it is continuous. So it's not fixed. I don't know if this clarifies what I'm trying to say.
Yes,
Dolan,
it
are we good
does.
now?
Yes,
Okay.
so just to get speaking right. So
Yeah.
classification is like when you are trying to get your target maybe into getting yes or no, binary or anything, that kind of thing. You're just trying to classify basically,
Like
right?
classify classes, yes. That you can see that the target are in classes, yes.
Just my own brain, oh, sorry, oh. But
Okay.
categorization is when you're trying to predict something like especially numbers, right? Oh, okay, the outcome of this one is going to be maybe let's say 0 0.4. This is what maybe the model was like try to understand the way this particular thing works. And then if you want to predict his own number based on the way it has understood it, then it should be predicting the exact number. This is what it should predict out. This is what it should predict out. This is the number it should predict out, that kind of thing. So that's what I used to use to understand it. So when you and I explained, I was like, ah, what was this one again? Sure, you don't know that machine learning. So yeah.
Oh, okay. So now let me just go for that test. Now, this is one of the reasons why for regression, you see us talking about mean square error, root mean square. Do you know why? Now let me explain why. Why is because let's assume that the price of this apartment, let's say that it's supposed to be 10 million, right? Now the model predicts, let's say 9.7 million, which means that there's an error, right? Maybe like an error of like 0.3 million. I'm just, there's an error with that stuff, right? Now, but with classification, let's say we are supposed to predict cat, the model predicts dog. So you already know that, oh, the answer is supposed to be cat, right? Not dog, as you predicted. Now you can see that it's classes. But with regression, which is why you see that you always most likely use either you want to use mean square error or you want to use mean absolute error because it's like the price is supposed to be 10,000, but the model is predicting 9,800. Something is it means like you can see there's a difference. Is the what is predicting is slightly different from it's close, but there's an error, which is why you can see for regression, the focus is mostly on error matrix compared to classification is either it's accuracy, it's precision, it's recall, or F1. I
Oh,
don't know if you get what I'm trying
yes,
to, yeah.
yes, that's true.
Okay.
Yeah, OCB, all those accuracy, precision, F1 score and all of those ones, they fall under classification, all right?
Yes. They fall under classification, yes.
Okay, thank you.
Yes. Okay. So just to answer Ngozi question, right? I think Ngozi said, how do I know the model algorithm to use? So the thing is you can't know the model algorithm to use. Let me see why. Why is because you have to try different algorithms. Now, so here's the thing, right? Now, there's always like a concept to it. Now, if I'm working with image data, now they can tell you that the best class of algorithm to use is neural network. Now, the reason is based on previous studies or based on previous solutions. The algorithm, the class, I'm not talking about the particular, the class of algorithm, because when you talk about class of algorithm, you're talking about linear algorithm, tree-based algorithm, then the neural network. When you talk about neural, you talk about, I don't want to go deep into that, right? Now, but you're talking about the class. So for image data, because of previous study, now the best class of algorithm to use is the CNN. That's the neural network rather, right? Because like I said, based on previous study, it has been proven that for image data, you most likely neural network will give you a better result than because neural network works it works similarly to the way the brain works, right? Now they will not tell you that for tabular data, the best class of algorithm to use is tree-based. Now, tree-based now it's not dependent whether you want to use random forest or you want to use. Now you can see that you've already limited it. Okay, I know that when I'm working with tabular data, I have to use tree-based algorithm to give me the best results. Now the question is, which type of tree-based algorithm will give me the best results? Is it going to be random forest? Is it going to be decision tree? Is it going to be XGBoost? Is it going to be light GBM? Do you understand? So you now try out these different algorithms to see the one that you can now go with. I don't know if you can. So you have to, it's like you have to try different algorithms to pick out the best. That's just the way it is. Which is why you have something like grid search. Which is why you have something like a parameter tool. Like you could try 20, you check the results, you change the value to 40, you come and check the result. Why are you doing that? Because you can't say whether 20 is the best value, 40 is the best, but you have to try out these different numbers so I can know the best one to go with. So I don't know if this answers your question, Ngozi.
Please, sir, it's not clear. That the model algorithm you just explained.
So I was saying that, yeah, there's linear algorithm, there's tree-based, and there's the neural network. Now let's forget about the is for deep learning. So we are not doing deep learning, so let's forget about this, right? Now let's focus on linear and tree-based. Now when you're talking about linear algorithm, for linear, you're talking about logistic regression, right? You're talking about the linear regression. There's also the KNN. SVM was not linear, but most likely put it in another. So these are like different. Let me just stop here. For tree based, right? You have random forest, you have XGBoost, right? You have light GPM. Now I'm still going to explain this algorithm, which is why I'm trying not to just go. Sorry?
Decision tree.
Yeah, it's just it's there. So I just listed a few, right? So now, so what I was trying to say to Ngozi is now the question is, how do you know the type of model I'm going to use, right? You can't know until you try. Do you understand? Now look at something. Now most of the time you have different algorithms at your disposal. So the only way for me to know which one is best is when I try all of them. And the one that gives me the best result, that's the one I'm going to go with at the end of the day. Right? Now, what I was trying to say is that you have different classes of algorithms. You have linear, you have tree-based, you have neural network. Let's forget about
Sorry,
neural network. Now,
but
for
because
linear algorithm, sorry?
so if that's the case, like you said, we don't really actually know the best, right? But why are people still
Yes.
now using a parameter tuning to still like tune it to still get the best results, even when we don't know the one that will give you the best results when you're working on your model? And that's why I feel like a lot of people are still coming up with like additional models and all of that. Just my own thing.
Okay,
Just
okay, so now let me let me answer that, right? Now, you see, the reason why you use a parameter tuning is because you're trying to improve the performance of a model. Now, let me explain. It's like saying if I want to determine the best model, I need to be sure that the different models the different algorithms that I've tried, I tried them to the best of their ability. Do you understand? Now, if I'm going to try them to the best of their ability, it means for each of those algorithms, we need to tune the hyperparameter. If someone comes and tells me, Victor, I tried XGBoost, I tried Light GBM, I tried Card Boost, and Card Boost happened to be the best. The question I'm going to ask is, did you try tuning each algorithm? Tuning on me, did you try like changing the values of each algorithm to be sure that Cardus is really the best. Person can say, ah, no, Victor, no, no. You should have do hyperparameter tuning. Okay, you now say that, okay, Victor, after changing the parameters for XGBoost, changing parameters for light GPM, going with the best parameter for each of these algorithms. After going the best parameter for each of these algorithms, card boost was still the best. Now I can like, oh, my final algorithm is the card boost, right? So for hyperparameter tuning, it's for each algorithm, right? If I'm going to try XGBoost, I need to tune it to the best of its ability. Right? If I try like DVM, also what tune into the best of our ability, right? Also try card boost, tune into the best of our, so after tuning to the best of the ability, we can now pick out which one is now the best out of this. Oh, and then this card boost. Oh, and then this. I don't know if you get what I'm trying to say, Belong.
Yes, I do. Thank you.
Oh, okay. Okay. So so I was saying that there's linear, there's free boost, right? Now, you see, with linear, the problem with linear is should I start? Okay. The problem with linear is when the number of data increases, there's a reason why it is called linear, right? The reason why it's called linear. Linear will mean that once you have two classes, it's just two classes, whether it is this or it is that. And the moment you start having multiple classes, right? Maybe like 5 classes, 10 classes, you're trying to class whether it is this or it is this. I mean, like in your target variable, you have 10 groups. It becomes a problem, right? So it means you now have to now change to three-bit algorithm because three-bit algorithm is built for something like that, right? Now, what I'm trying to say is you can't know the best algorithm until you try them. Now, if you're going to try each of them, it means for each of those algorithms, you have to tune it to the best of their ability. Before I can say hard boost is the best algorithm, it means I already tuned or I already changed the values in light GPM, or right? After changing, the highest value I could get from it is 90. The highest value I could get from card boost after tuning is 96. The highest value I could get from XG boost after tuning is 92, right? So because it's like I've tried every single thing I know, and the best is card boost. So it means I already know I'm going to go with card boost, right? So which is why I was just trying to that, oh, you have linear, you have tree base, you have neural network, right? But you're not talking about linear, so you just focus on linear. So the only way for you to know is by trying. So if you don't try, there's no way you can try to know the best. So I don't know if this and just what you are saying. MS. Can I continue, please?
Yes, you can continue.
Oh, okay. So I was just trying to explain, so I can remove this, right? So this is just me just looking at the this is just me just looking at the category. So we have 3 categorical columns: customer ID, gender, and default next month. Customer ID is useless. It's useless to us now because it's only just uniquely identify as customer. So we don't have any business. So it means we have to. If you ask that which column are you going to drop, you are going to drop you're going to drop customer ID. Right. So let's drop customer ID. But before I drop customer ID, let me just create a copy of the data. Do you understand? So um sorry. Please, I think I made please can just let people in. I think I made Linus if you're on the call and posting the post. So I'm trying to just create a copy of the data. You understand? Just creating a copy. So you get so you just be working with this, right? The reason why I'm creating a copy is in case you might make a mistake. I'm just saying, like, when you something, yeah. So instead of me going back to running from beginning, I've already created a copy somewhere, so I can just go back to run the cell and just get what I'm trying to say, right? So now like I said, we do not need the customer ID column because so it's not important, right? Now there's something called noise, right? Noise will mean so if we say noise will mean so when you hear anybody says noise is something that is irrelevant. If you are listening to music, if you are listening to something, you could say, oh, I could get something, but some of the things were irrelevant, some of the things were useless, right? So the customer ID is useless. So there's no business. There's no business having it. Yeah. So what it means, we can actually just drop it. Drop the ID. So let me just copy instead of having to type again. Just copy it because it's useless, right? It does not give us any information. The only information it gives us is it's just you need to tell it's just telling you that, oh, We have 30,000 customers. Okay, so what next? Charlie, we don't need it, so we just drop it, right? Which is why we have to just, which is that we have to just drop it. So that's just it. So we are going to drop customer ID. You can see this, right? Let me run this. Did I run that before running this? Still, what's the problem?
Tavitos, sorry.
Okay, yes, please, go ahead.
Oh, you not specified
Please
the
go
app.
ahead.
Oh, okay. Okay.
Okay. No, it's I'm trying to see. Did I run this before? Running that. Okay, good. So now let's do df dot process. Now let's
Sorry.
check it.
This one is just like you're just trying to explain the suffix, right? You've not fully done
Sorry?
it, right? This is just the suffix, right?
I'm confused. Suffix as no. I don't get.
Like, have you started machine learning properly? Or this one is just maybe like
We've not started creating anything. You're still trying to create. So look at this. We are just trying to process the data. Before you can start creating any model, you have to process. You have to clean it before you can now. Because remember, garbage in, garbage out. So if you give a machine something that is nonsense, something that is wrong, it will give you wrong output, right? So you're just trying to clean the data before we start creating the model. So it's like saying, looking at this customer ID is useless. So there's no need encoding it. It does not give any useful information to the model. So let's drop, which is what we did, right? Okay. Now remember, I also highlighted the fact that we actually have some categorical column, right? So which means that the other categorical columns we have nice object
Sorry,
is
Mr.
okay. Yes, please go ahead. Please go ahead.
The categorical column. I think we have
Yes.
tried to extract it from the general DF. Now we
Yes.
make a copy of DF. Are we still going back to a categorical column after we must have dropped a customer ID?
So
Because
is
I was
it
thinking that
okay?
yes, I was thinking that the customer ID is going to be dropped from the categorical column.
I don't understand. Customer ID you just I don't think I get
No,
what
what
you're
I mean
trying to
is
do.
this: you already define the categorical column here
Yes, yes.
from this. Now you
Okay.
went back to df underscore process.
Okay.
You define it as a copy of df.
Okay.
So what is the significance of this categorical column? That's what I want to know. Or it's just
Okay,
for us
so
to know.
it's just for us to
Yes.
know that these are the categorical columns. I don't know if you get what I'm trying to say. The reason is I was saying that instead of you going through the store I was saying that customer ID is objects. So instead of you going through it manually, you can select those columns that like this is just for us to see those columns that are categorical columns. I don't know if you get what I'm trying to say. It does not have anything to do with the data. Do you get what I'm trying to say? They're saying which columns are categorical, customer ID, gender, or default next month. Do you understand? So we already know that these are the columns we have to encode. I don't know if you get what I'm trying to say, please. This is just us just trying to see those columns that are
Is
categorical
all right,
columns.
sir. Yes, I got it.
Oh, okay. Oh, okay. So now that we've dropped the irrelevant feature, right? Now what we are going to do is to encode because now based on what we've seen, it is gender and default next month, right? So what we are going to do is to now encode encode this stuff itself, right? So this is what I should do, right? Let me just copy this. I don't want to start having to write this again. So I want to just make it easy. So let me just change the df the process. Now the reason is I want to encode, so instead of encoding it manually, so let's use the for loop, which is why I want to run this again. Okay. So now category I now have gender and next and default next, right? So I want to encode it. Now this which is sorry I'm going up, I just want to show you which is where we need this label encoder. Can you see this now? Which is why I imported this. Now before should I okay let me just see this, right? Right. Let me just put this let me change this to text markdown and just write coding so you get what I'm trying to do. Sorry, encoding. Right. Okay. Now, so when it comes to encoding, there are different types of encoding. Right. We have label encoder, we have one-hot encoder, we have ordinal. So I'm trying to think of a very simple way for me to explain it. Now the thing is, like I said, the reason why you're encoding something is because it is categorical, right? And because the model cannot work with. So it has to be in a coded format for the model to be able to work with, right? So because the model need everything to be in numerical format. So it means every single column that are categorical, we have to encode. Encode will mean we have to convert some categories to what numbers, right? The question is, which different techniques do we have? We have label encoder techniques. We have one encoder techniques. We have this one. I'm trying to remember. Ordinal, yes, you also have ordinal encoder techniques, right? Now, you see for one hot, I'm trying I'm trying not to I'm trying to think of the best way I can explain it. You see for one hot will mean that you can try to create different. Okay, so now, let me put like this. Let me put like this. So if, for example, now I have the gender column, right? Now the gender column has male and it also has female, right? Now, if I'm going to use label encoder, now this is how it's going to be. Now it depends. So label encoder, what it means is male will be 0, female is going to be 1. Do you see it? So it means that every single part where, let me just indicate. Please, I don't know if I made, I think I made. Okay, please, I think we listen to me. Thank you. Now, if I use label encoder here, for example, right? This is what it's going to be. It's going to encode this, right? I'm going to have 0 and 1, right? Now, but if I use one hot, right? We are still going to look at it, right? If I use one hot encoder, let me explain what is going to happen. And what is going to happen is, the original column you actually had 0 and 1, right? Now, what is going to happen is you are now going to have different columns. You're going to have two columns, one for male and one for female. Now, so what this would mean is that anywhere anywhere the person is male, here is going to be, I'm just saying, anywhere the person is male, here is going to be 1, right? And here is going to be 0. Let me remove this. Sorry. So you don't get confused. Which is why it's called. So if, for example, let's say the person's name is Ibrahim, for example, and let's say here the person's name is Esther. But I'm just trying to explain something. Now, because Ibrahim, obviously, the general column Ibrahim is male and Esther is female, so it means it will create one of the coda. What it's going to do is going to create two different columns, a column for male, another column for female. So because Ibrahim is male, here is going to be 1, female is going to be 0. Can you see this? Now, because Esther is not a male, what happens? Here will be 0, and here is going to be 1. This is why it's called one hot, which means 1, the rest are 0. One hot encoder, which means for the place where that stuff is going to be 1, why the rest are 0. We don't care about the rest. To be 0, which is why it's called one hot, which means 1, like 1, which is why you can see Ibrahim is 1, this is 0. Can you see this? So let's say that we also have 20, for example, right? Now that will mean that here is going to be what? Here is going to be 1, and here is going to be what? 0. Can you see this? This is for one and encoder. Let me just. Now, you can see the general column. You can see the what it just does is for we case where male, it just represents male as 0. Can you see this? Female as 1. Can you see this? It just automatically assigns value to the encoder. What it does of what creates two different columns based on what we have, it's only male and female. So the question will be, Victor, what if general, let's say we have male, female, not use gender. Let's say we have something that has what it will mean is it will create what 3 different columns. So the only place where that particular value is will be 1, which is why, like I said, it's called one. You understand, right? Then for the ordinal, let me just last thought. for the ordinal, encoder. Now, what it does is it it encodes based on what's the word now? It encodes based on how similar the stock is. So if I say high, low, and medium, right? Now in this case, now you can see these are related medium, right? And high. If I'm using ordinal, that will mean that low is the lowest. This is 0, this is 1, this is 2, this is ordinal. We can see there's a relationship between the values. Do you understand? Now, in this case, we cannot use ordinal encoder because I can't say male is now. I can't say female, so it does not make any sense actually, right? Now, you can either use label encoder or you can use one encoder. It's you. You can try label encoder, see the results. You now come back again and try one encoder. You also see the result. Then you pick the one that gives you the best result. But for ordinal, we can't use ordinal for gender because we can't say, oh, the male is higher than me. We can also say female is higher than me. So it's not ordinal. So maybe for example, if for example now, let's say education, say for example, you have a column called education. And now for education, you have, let's say BSc, you have master, right? You have PhD. Is this ordinal? Yes, because it means you have to get your BSc before you can get your master's, before you can get your PhD. And so you can see it follows a pattern. BSc first, master's first, PhD. So in this kind of scenario, you could use ordinal. Now, that doesn't necessarily mean that you can't use label encoder for this. I'm just trying to explain the difference between label one encoder and ordinal encoder. Let me just create this, right? I don't know if I've been able to like do that, right? So if this is clear, just drop one in the chat so that I can continue. At least if I'm not too fast, I want to cover this thing. I just want to cover. Is there anything in store for our machine learning? Nah, not yet. No. Don't. It's only in later part when we want to deploy that you will need to install Streamlit, but not now. Don't worry about now. Right, which is why we need to we need to cover this thing as soon as possible because we literally do not have time on our side. Okay, so I guess I can continue, right? I'll be done in the next 5 minutes. This is almost 9. Okay, so I think I've been able to explain the difference between one and likes, right? Okay, so let me move this up so that it does not affect what you are doing. So this should be up now. Sorry. Okay, label encoder. One not encoder. This ordinal, calm down. Sorry. What am I doing now? Okay, calm down soon. Yes, okay. So now let me bring this down. Okay, I think that's okay. That's I think I was just okay. I think I was just trying to explain something, right? So I think I can break this down now so that it does not affect what you are doing. So yeah. Okay. Okay, good. Now that you've identified that we just have gender, default, next one, blah, blah, these are the two categorical columns you're going to use, right? Now, this is what we are going to do, right? I'm going to use a for loop so we can just do everything, so we can encode everything at once. I don't want to start, this is what I'm trying to say. Imagine you encoding the agenda first, then you now come back and code. Let's just do it at once, right? This is where you get to use for loop, right? So I'm just going to say for column in categorical column. So this is what I'm trying to say. I'm trying to say, you know what? So far it's in this category, I just encode it, right? So we don't want to be doing it one. So imagine you had 100 columns you want to encode. You can't be doing one by one, right? You want to just use your for loop to just do it, right? So let me move this here. So label encoder, this is where we get to use it, right? Sorry. What am I doing? Wow. So I'm gonna I think let me try to write it so it's easy for me to just explain at once. Okay. I'm going to explain what I'm trying to. I'm just trying to write everything out. So it's easy for me to explain. Uh, this is just me just wanting to. So let me just create a dictionary so that you can see. So sorry. Okay. I'm going to explain what I'm doing. I just want to write everything at once. Okay. Now let me explain what I'm doing. Okay, let me just quickly do that so that I can explain what I am doing. Right. Okay. Maybe I should just add this. It's not really necessary actually, but okay. So now look at something, right? Now let me explain what I did. Now, when you do label encoder, you always have to use key and transform. Let me explain what this means, right? So the first thing you have to do is because we are doing, you know, before now we did classes now. So you still remember how we instantiate our class, right? So you just create an object of that class, then now you just continue, right? So the same thing too, we already imported label encoder before now. This is what we are gonna do, right? So it means this is what we are applying to each column, right? So you can see, which is why I said which column have a categorical column that has gender. So I'm saying for each of these columns, these categorical columns, please encode them. Encode. First off, you define this. Remember, you don't have to always use LE. You can use something else. I'm just using LE for short encoder, right? After defining that, you now do LE fit underscore transform. Now, let me explain. Why you say fit underscore transform? Now, before the stuff can transform something, you have to like saying, I want to transform something. Yes. So the question is, what do you want to transform? Let me first of all come. It's like you're taking the coder to the column before you now transform it, right? So when you say fit is like it will understand. So when you say fit a lot. So during that fit, what happens? We stop understand the column. You understand? Okay, male, female. So means male will be 0, female will be 1. Okay. And most of the other one, before next month, yes or no. So it means yes will be 1, will be 0. Okay, very good. So what it means is that I'm now going to assign 0 to this, 1 to this, 0 to this. Why? Because so doing that fit process, try to understand it before I can now transform it. Right? So this is why I say fit on the transform. So two operations are being carried out. It is understanding the data just so I can what transform it. You understand? So that's just if we if I now let's just print label encoder so you can just see it. I think this is where I'm gonna stop. I wish I was able to go past this. But let's check the data so you can see it. Can you see gender? Can you see the 0, 1? Can you see that's encoded? Let's check it. Can you see default net? Can you see this? 1, 1. Can you see this? Can you see it's no longer yes or no? Can you see that's already encoded the value false? So let me stop it to see if this is clear. If this is not clear, please let me know so that I can explain it again. Okay, so if it is clear, just drop on. It's not clear. You already dropped it there. Okay, so let's do this. If it's drop one in the chat. If it is clear, drop 1 in the chat. If it is not clear, drop 0 in the chat. Right. If it's clear, drop 1 in the chat. If it's not clear, drop 0 in the chat. If it's clear, drop 1 in the chat. If it's not clear, drop 0 in the chat. Okay, it's not clear. Let me let me try to explain it again. How to explain it? Okay, so now here's the thing, right? I think I did explain the difference between label. I'm not going to that. I want to encode something, right? Let me give this particular example. Let's assume that I want to create a particular type of furniture, right? Because I want to create a furniture, I decided to call a carpenter. Okay, you know what? Come, I want you to create something for me. Now, the carpenter cannot just start working. The carpenter needs to understand what I want. Oh, this is how I want the stuff to be. This is how I want it. The carpenter needs to understand what I want before the carpenter is able to what, do that for me, right? Good. Now, what it means is, before you can use label encoder to encode your data, you need to understand the pattern in your data first, so that you can now encode it. Now, what it means is you have two operations. You have fit and you have transform. Now, see, it understands your data. Let me use that word. Now, what it means is it knows that, okay, in this particular column, gender column, you only have two classes, male and female. So what it means is when I want value, I'm going to assign a number to male, I'm going to assign a number to female. That's already understand the gender column. Now it moves to the next column. The next column is default next. Okay. Now default next month only have two classes. Yes or no. So what it means, I'm only assigning two numbers, right? 1 to yes, 0 to no. Now that I've already, I can now start assigning, which is where this transform comes into play. This is where it now assigns the number. Okay. Now it's now assigned to number. You understand? Now, so what it means is we could have done something like this. Maybe I should just write so you get what I'm trying to say. Now we could have done something like this so you would have better understand it. Right? We would have done something like this. So let's say fit. Let me just do this. So let me just say let's say fit data, for example. Right? I'm just trying to explain something. So you get what I'm trying to say. Sorry, don't mind me. Let me just move this first. I'm just trying to explain something. Now this is what I would have done. I've just done this dot fit thing, and I've now done this dot transform. Now, can you see this? Look at something. Can you see, look at this? Now you can see the first thing we did was to fit. Now this fit, it means it understands a pattern. Can you see this? Here is where you now get to what? After understand, you can now it's now able to the data. Can you see this? You understand it. Now instead of writing two lines so there's this thing that allows you to do everything at once, which is why it's called fit underscore transform. So you're understanding, after understanding, at the same time, you now what you can now assign. I don't know if this is clear now. So it's fit, it's trying to understand, transform, so you can now encode and okay, there are two classes only assigned to value. So since I already understand that, I can now start assigning gender, let's maybe 0, let's maybe 1. Okay. The next is before next month. Let yes be 1, let no be 0. You understand? So that's what it does. So you think this is not necessary. Don't mind me. Let me even remove it. So you don't get. So these are the two. It's just because these are the most important thing. You understand? Create an object to that class, then you now what encode. That's all. So when we did that, which is why you can see that we now have it. So is this clear now? Please? If it is, you can just drop on in the chat. If it is, you can just drop on in the chat.
Okay, so Mr. Victor, a quick question. How
Yes,
did this know that? How do we know male different from female? How do we know that male is 0, female is 1, or female is 0, male is 1?
so what it does is it just adds numbers to the different classes. So it does not know
Okay.
whether it is zero. And just like say if I say, oh, let me change this. Once it sees two classes, computer start counting from zero. So the first class you
Yes,
assign
yes.
zero, second class. So if it were three classes, it would be zero and two. You understand? If it's four classes, zero, one. So it's just like assigning numbers to the different class. So I don't know if you explain what I'm trying to do.
Okay. So it shows I need to be familiar with the table. Probably I would know that this one that it's assigned zero, I have male on the first row.
Yes, yes,
Okay.
yes, yes. You need to yes, yes. There's also a
Okay.
manual way of doing this. So you can manually assign values to this yourself. You can use map.
Okay.
You understand?
Okay.
Map. So there's way for you to do it yourself. I can use map, but why do it yourself when you can just let it store this for you? You need just for you to understand. Because if for example, let me just. I think before now. Sorry, I'm trying to go. I just where's that place? Sorry, I'm going up. Now. See.
Hello guys, can you hear me? Okay, I think Mr. Victor is now. Okay.
Yes.
Sorry, but people, you can easily just this. Okay, so you can easily just descend that. Because if this is female and male. If I scroll down to where we stopped, you can see female. Now me female is zero, male is one. You can see this. I think there we saw yes, yes, which means yes is one, no is zero. So that's just the way. So let's just stop here, please. We'll continue in the next class. Thank you. Okay, so in the next class
Thank
we'll
you.
continue from where we stopped. Yes.
Thank you, Mr. Victor. Thank you.
Yes. You're welcome.
Thank you, sir.
You're welcome.
Thank you, Mr. Victor.
Yes, you're welcome. Everybody's running to go and watch Nigerian match. I actually want to watch Nigerian match. It's just quite sad that Ghana no longer.
Ghana is still there now. Their referee is still around. So,
Then I wanted to look for trouble this evening. That's why. Oh, Linus is never. Linus, are you there? It's quite sad. You guys are no longer in the tournament. Wow, wow. Sorry about that. You can feel free to watch the match actually. You understand?
Mr. Victor. That's run away. The